Dean, for coming into this university. Is this your first time here? Yeah, first time in BOGOR. Okay. So Dean Joyce is a PhD student from University of Nottingham. He's doing research in Riau. Yeah, and so we're going to listen to his presentation today. But before that, I would like to invite Dr. Gianto to officially open the seminar. So this is a seminar that hopefully we can be conducting every month or bi-monthly. Yeah, so we will see. So the department is going to be more active in conducting our research and reaching out also to beyond the department. So this is a new start. So Pak Gianto has just been elected as the head of the chair of the department. So he's new. Yeah. So congratulations, Pak Gianto. We're very happy that you are our chair now. So yeah, one of the goal of the department is internationalization. So it's really an honor to have you here, Dean. So first of all, let's welcome Pak Gianto. Monggo.
Thank you, Ibu Dami. Good morning, everyone. Assalamualaikum warahmatullahi wabarakatuh. First at all, I think let's thank to Allah Subhanahu wa Ta'ala, God Almighty, because of His mercy and also goodness, we can gather here to have seminar with the title River Medicine Restoration and Oil Palm Plantation. You know, oil palm now get the moment. Iran war, I think it's our moment to more and more how to manage the palm oil plantation, because I think we have ambition to have to replace the oil from Arab country to biofuel. I think this seminar will be very interesting. But first at all, I would like to thanks to Dean for your coming here and for your sharing. I myself is Gianto, head of Plant Protection Department, did not elected actually. Selected also, whatever. I should be here, and we would like to increase our atmospheric academic, and I hope students will be very active in the next. Forum Wacana, for example, from postgraduate student association, also Himasita, undergraduate student association. Please be active to conduct the kind of this seminar, maybe also from a possible look like Dean from other country, or maybe also you can seminar by your master research or PhD research, so we can share everything and increase our knowledge in plant protection. Again, that the seminar I think will be very interesting for us to have our inspiration, and don't be hesitate to actively ask to Dean, and if possible, you can make contact with him for the next collaboration. I think it's very important because you are as the next scientist, and also the age I think the same with Dean almost. So I think you will be together to grow as a scientist in the next, and collaboration is the key for your further career. That is our speech remarks from department. Again, we will support of this academic atmosphere to more and more you have any possibility to increase your knowledge, your inspiration, your collaboration in scientific base. Thank you for your attention, and thanks Pak Pur, Bu Dami, that very active scientist. I think we are proud with both of them. That I think IPB itself is very proud to Bu Dami and Pak Pur with high, I mean, publication impact and also collaboration with other countries. Again, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Okay, so Ani, are you ready? Not yet? Okay. Jadi presentasinya ini beliau menyiapkan dalam bahasa Indonesia. Nah, makanya mau membacanya dalam bahasa Inggris, jadi ada notes yang harus dibaca. Nah, kalau notes harus dibaca langsung dari situ kan bolak-balik ya. Nah, jadi ada duplikasi di situ. But we'll work it out. So let me read his CV. So, okay, Dean Joyce. Oh, I like this additional information, so I'll start with that. So Dean has a strong passion for the outdoors and all things living. All things living. So also have experience guiding small team hikes, a wild campaign through the Peak District, Lake District, and Scottish Highlands. Oh, wow. So if you want to go to Scottish Highlands, we can go with you, yeah? Okay. And he has received his bachelor with honors, yeah, from horticulture. Ya, jadi bidang ilmunya hortikultur, ya. And now is a PhD candidate at University of Nottingham. And he has many experience before he entered his PhD program, has worked in various types of skilled jobs from British Airways and then British car auctions, Grove Social Care, and then also Amazon, and Lidl. What is this? Oh, it's a shop. Yeah. Okay. Wow. Okay. Really great. And then his core competency, field and laboratory research, experimental design, literature review, data collection, quality assurance of samples, statistical analysis using R, Excel. And his dissertation for bachelor's is, can altering growth method of oil crops influence oil yield? What type of oil crops was this? Grape? Ah, okay. Okay. So you've been working with oil crops and now you're working with oil palm. So oil and no oil palm. So that's why he has to come to Indonesia. Also, he has vast experience in soil science and sampling, acoustic and environmental monitoring. Oh, okay. Field logistics. And then technical software, AutoCAD, SketchUp, layout, Microsoft Excel, and RStudio. And then for practical field skills, since he's working in horticulture before, he's very good in pruning, small constructions, and horticulture, mushroom, herbs, perennial. Wow, you have so much skills. Oh, wow, that's wonderful. All living things, that's why, yeah. Okay, so here today there are PhD students here, and then master student also. There's PhD, right? Ada Marish kan? Okay, yeah. So, and also Ola and Bella. Okay, so we have PhD students here, master students, and also bachelor, and also research assistant. And then on the online, how many do we have? Selamat datang bagi berapa? Selamat datang bagi teman-teman yang sudah ada di online. Terima kasih sekali sudah hadir untuk hari ini. Hari ini kita akan belajar banyak tentang penelitian di Dean Joyce yang akan bercerita, membagi informasi tentang penelitiannya bagaimana merestorasi kawasan-kawasan di pinggir sungai ya pada kelapa sawit. Jadi ini salah satu bagian dari regenerative agriculture, katanya bagaimana sawit itu bisa menjadi lebih sustainable. So, Dean, welcome, and we're all excited to hear your presentation. So the time is yours.
Hello, everybody. My name is Dean Joyce, and I'm a PhD student from the University of Nottingham. Thank you all for attending this session. I understand some of you have exams going on. And yeah, thank you for having me here. It's a great experience. So, yeah. So a little bit of a background about me is I started my journey doing a bachelor's in horticulture, where I was working in gardens and estates in the UK. And what we do there is try and improve biodiversity by planting, designing borders, where we would, again, just try and introduce more pollinators. So when the opportunity came to work on a restoration project in an oil palm plantation in Indonesia, I couldn't refuse it, especially with my research being on the hidden half, the soil and the leaf litter communities, as well as their functions, so how they interact with these restoration treatments. So a little bit of a background about oil palm. I'm sure many of you already know how important it is. But typically the world operates on supply and demand. So we need to ensure that there's a demand for a commodity, that we have enough supply. And Indonesia is the leading producer of palm oil, producing more than half the global output. And in terms of demand, well, there's a definite need for it. In the UK alone, while statistics do vary, they say that up to half of supermarket products contain palm oil or its derivatives. So this is, it's in everything from cosmetics, so makeup, lipsticks, shampoo, foods, so chocolates, biscuits, cakes, and it's also used in biofuels. So I don't know if many of you know, but petrol in the UK is yellow, but over here, especially in the rural areas, petrol is green, and that's because palm oil derivatives are actually used in the process of making it. So there is a clear, it's clear that palm oil does power economies and livelihoods, especially for smallholders, rural communities. However, the expansion in cultivation over the past few decades has come at a steep environmental price. While expansion is not so bad in recent times, but if you go to these rural areas, pretty much everywhere you look, you'll see oil palm. And it has broken apart native tropical forests and pushed species closer towards the edge through habitat fragmentation. So this worsens the effects of poaching. So endangered species such as Sumatran tigers are often scarce now. But there is obviously a clear importance of the production. So we need to find a balance between this production of oil palm and sustainability. So one powerful method that we can actually use to fight back are these strips of vegetation alongside rivers, and these are known as riparian buffer zones. And these can be natural, so it can be native vegetation. They can be restored, so it can be planted vegetation, or it can also be retained. So typically for sustainable palm oil certification, they require these buffer zones to have to be sort of maintained, and the business as usual practice for this is to retain mature palms in these areas. And these also are very important because they act as a transition zone. So they protect the water, they protect wildlife, and they also protect the land itself. So it is important to note that this tiger is not real, just to put that out there. And why do these landscapes, why do these zones really matter in these landscapes? Well, again, as we can see, the difference, they do provide cleaner water, safer homes for endangered species, and also stronger banks. So by having these stronger riverbanks, we can have better long-term yields, because if these riverbanks are eroding, then producers will lose yield over time, which again can affect income and may cause worse problems further down the line. So we at the RERTA project are putting this to the test. We're testing 4 alternative restoration treatments to help identify the best method of restoring these buffer zones. And again, as per the certification standards, which the business as usual practice is to retain mature palms. We have this as our treatment B. We also have our control group, which is treatment D. So this essentially we want to, perhaps the communities that are already there, because these plantations have been going for so long, maybe the communities are so dominant that actually these restoration treatments aren't going to introduce much change. So it's good to figure out that. We also have enrichment planting. So it is important, again, that all these treatments coincide with the replanting phase. So typically, I'm sure, again, as you know, after 25 to 30 years, oil palm needs replanting due to difficulty harvesting or declines in yield. So during this replanting phase, we had the treatments implemented. And for treatment C, we have enrichment planting. So this is clearing of the mature palms, followed by planting of 6 native tree species. And then we also have treatment A, which is a combination of the mature palms and the enrichment planting. So we can sort of pull apart what is actually driving any changes that we see. These treatments, so the buffer zone is 50 meters wide, and each treatment spans 400 meters in length, parallel to the river. And it's across 2 rivers in Riau. And yeah, so RERTA, the Riparian Ecosystem Restoration in Tropical Agriculture Project, is a major collaboration between many institutions worldwide, including Sinarmas Smart Research Institute, IPB University, yourselves, the University of Cambridge in England, and the University of Nottingham, also in England. And our main goal is crucially to directly inform these buffer guidelines for sustainable palm oil production, as well as also offering essential improvements to management practices in tropical landscapes. That is a real Sumatran spitting cobra that I encountered in the field. Yeah, I've also encountered a very large king cobra that was probably 2-3 feet away from me. So that was very scary, but also very interesting. Thankfully, this cobra wasn't so close to me. And yeah, so for my project in particular, I'm, in my opinion, focusing on the most important areas, which are the soil and the leaf litter layer. And this is because, to me, this is where the real magic happens. These layers, they drive everything from cycling nutrients for the above ground vegetation. They store carbon, so helping reduce the impact of greenhouse gas emissions. And they also hold water, so a good water holding capacity is essential in these tropical climates where you have a dry season and really harsh heat, sunlight, etc. Yet they can be overlooked, so it's important that we focus on them. And even though they do directly relate to many crucial functions, one of the biggest reasons that these layers matter is because of the time it takes soil to form, which can take up to 1,000 years. So that's a whole millennium to form the top 1 centimeter of soil. So if we degrade these layers faster than they can recover, then we are risking the future of these landscapes as well as the people who live in them. Oh, okay. Oh, there we go. So the surveys I am using to test the restoration effects on these hidden functions are a mix of tried and true, so we know that they can give us meaningful data, and also some novel tools, some pretty new developing tools that are sort of gaining more traction, which I'll get into in a second. But we're also conducting vegetation surveys. So typically, I mean, as we can see in these 2 lower pictures, that the habitat characteristics vary widely between plots. So it's essential that we record these, and then in our analyses, we can actually try and pin down what these characteristics, what are their effects on the results that we're finding. So in terms of the first one, leaf litter decomposition, this directly ties to nutrient cycling, soil fertility, soil health, and overall ecosystem health. And for this, we are using 4 bags. There's 8 there, but we're using 4 bags which are collected at different intervals. And this is essentially so we can calculate the mass loss over time and assess if any of the treatments actually speed up or slow down this crucial process. We're also using, so the reason why we have 8, as you can see in the bottom 4, they have holes in them. And these holes are to allow access to invertebrates, whereas the closed bags are so we can observe the microbe-driven activities, which you see in the bottom bags, there's 4 holes on each side. Just go up there. So right here, these, sorry. So these small holes, yeah, so that's to allow access to these invertebrates. And again, research already suggests that decomposition is microbially mediated. So the microbes are the drivers of this. But including them both gives us that additional comparison for our research. And then the next one we have is soil fauna feeding activity, so the below ground feeding rates. And for this, we are using bait lamina, which are these strips in that right image. And essentially, we fill them with a bait material, and we come back after a set amount of time, sorry, which is 6 days. And what we do is sort of count the open holes and the partially eaten holes. And this gives us the indication of how the below ground fauna is feeding, how active the different plots are. But not only this, we can also determine what is the most active depth. So as we can see in the bottom 2, so the feeding activity is typically in that upper half, which is probably what we'd expect because the upper layer of soil is the most active, the most fertile. in there. Yes, yes. So so these are the bait lamina sticks, and all this white material is the bait mix. And so we insert it into these bait lamina strips, and then here we can see the empty holes. So these would have been eaten by maybe earthworms or ants. Yes, so all of these are from the same plot. So we would have took this out, taken these out of the ground. So we put them in the ground, and then we take them out after 6 days, and we count each holes that are empty. And then this gives us our sort of feeding activity. Oh, yes. The bait material. So it's a mix between bran, cellulose, carbon. So it's pretty much the typical sort of organic material that these insects may feed on. And yes, we also record these. So we've been carrying this out since before these treatments were implemented. So they were implemented in 2018 at River 1, 2019 at River 2. And so we have baseline data from before the treatments were put in place. And then 2 years, every 2 years, we reconduct these surveys. So again, we can see how the restoration treatments are affecting these processes over time. And then we have the more novel survey, which is below ground acoustics. So this one has gained more traction in recent years. Typically, so what we use are these audiomorph devices, and most of the time these are used to record like bird noises, frog noises. But what we're doing, so the reason it's novel is because we're using it to record below ground acoustic activity. And yeah, so it's not yet been done, been tested in comparing river margin restoration and oil palm plantations, which is why we're the first to do it. So as you can see, I don't have any, I should have brought some examples with me, but there was a few issues. But what we can see in the top images is we did encounter a few issues in the field, whether it be rodents or other animals who are overly curious, destroying the equipment, which is the relatively low cost. But we started off with 20 of these kits, and we have 9 left. So that shows how rodents, monkeys as well, they come and they rip them apart, which is not good. So when I next come back and redo these surveys, I'm hoping I can find a way to improve the protection of them. Probably around £2,000. Yes. No. So in total, we spent, I think it was around £4,500 for all of the equipment, but we've lost over half of our devices. So we've probably lost around £2,500 worth of equipment, which is not very good. But we do still have plenty of data. We just had to sort of readjust in the field. So rather than deploying the audiomorphs at every single plot, we've had to reduce our sample size by half, unfortunately. But we're hoping we can still find some meaningful results, which actually brings me on to the next slide, which we have some examples. So these are called spectrograms, and what we can sort of see in these. So typically below ground activity is sort of this lower, on this lower frequency. And then these noises sort of up here are more above ground insects or birds. So we have some frog noises here as well. And these, where it's sort of yellow, that indicates that there's high activity. It's close to the microphone, whereas this, not so much, more low activity. And if we can actually start playing the sounds, I've created little sections that give you an idea of what we're listening to if the sound comes through. Yeah, so you can just click on each one. I don't think they're very long, maybe like 20, 30 seconds. So this is this top one. In the ground. So we have the contact microphone and we have a probe. There's a little metal needle that connects to the microphone, and we just put that in the soil, and it is around 4 inches. Yes, so we can record all of the below ground activity, but it also captures the above ground, which is pretty interesting. So that first one, I'm assuming, is a cricket. Again, this data was collected like 2 weeks ago, so I've not actually had the chance to go through it. So we're all listening to this. It's all new to us all. So this one, I believe, is a frog. I'm not too sure what is making these noises. So if anyone has any idea, I'm very interested to hear. So this one you can first initially hear whether it be a bird, and then these are all at 8 p.m. So in the evening. All that rustling, that is below ground. So that could be a worm, ants, could be rodents. But what we're hoping to achieve is we want to test different indices, whether it be your acoustic complexity index, your biodiversity indexes. But we're also trying to use what are called embeddings, which are to do with machine learning. It's pretty complicated. I'm still learning it myself. But we want to just compare all these different methods of analyzing this data because it's so new. So hopefully we can find some interesting things. Yes, she's the one who's helping me with the embeddings, which is all the machine learning. So that's why. Be a great help. Yeah, I think you have to keep skipping through because it'll keep playing. Yes, yeah. Yes, so testing and comparing these alternative restoration treatments is very good, very useful. However, in these huge monoculture landscapes, the real question is, how do these key soil communities which drive these processes, how do they find their way back to these plantations? Because if you've seen them, they are so vast that for me, it's hard to expect any of these crucial insects to find their way back to the landscapes. So research also shows that it can take up to 30 years for vegetation restoration to show meaningful results. So what we're hoping is we can actually give nature a helping hand. So this is the exciting what if part. So this is another novel experiment treatment that we're introducing, and hopefully it will turn out to be a simple, scalable way to speed up ecosystem recovery. So we're hoping by reintroducing the key soil communities early, we can actually accelerate ecosystem recovery faster than the restoration alone. And if successful, this would also offer a low-cost, practical management strategies for all farmers. So this image is an example of the soil and leaf litter in a native tropical forest, which is around 2.5 hours away from the plantation, it shows you how big these plantations are when the nearest forest fragment is such a distance away. So how do we do this? Firstly, we record our surveys to collect baseline data before we actually transplant this material, which is what I've been doing during my first field season. And then for the transplants, we take small volumes of native tropical forest litter and soil, and we put that into our riparian buffer treatments. Then we wait for a few months. So we are waiting for 6 months, and then I'll come back. So between September and December, reconduct the surveys, and hopefully we find something useful. We also have, so there's 2 treatments and a control. The control group, which, as we can see in this image, is it's purely the rota restoration treatment on its own, no transplants applied. And for the 2 treatments, we have substitutional litter transplants, which is replacing an equal volume. So as we're taking 520 centimeters cubed and 320 centimeters cubed from the forest, we also take that from the rota plots and replace it with the forest litter. And then we also have a low volume inoculation, which essentially is just adding the donor material on top of the existing layer. And this is pretty much so we can see, again, as previously mentioned, what if the communities that are already in these environments are so well established that actually we need to remove some of them before we can find meaningful results. So hopefully we can tell that. And we do have, so it's 3 by 3 meter plots, and these are situated outside of the existing rota plots where all the other surveys are conducted. And so each 1 meter squared, so 3 by 3, we've got 9 meters squared. Each 1 meter squared cell contains 520 centimeters cubed of the litter and 320 centimeters cubed of the soil. And now we have some examples from the forest. So in the top 2 spectrograms, these are just the ones that I showed earlier, the one with the pretty low activity. So again, there's not much yellow there, so pretty low activity. And on this one, we have a few areas of high activity, but because the rest of it sort of replicates the low activity, we could sort of assume that it's probably only a few organisms that are actually driving this high activity. Whereas in the forest, so these are from different times of the day. We've got 3 p.m., we've got 7 p.m., and we've got 9:30 in the morning. And we have this yellow all the way through. So we know that these forests actually do have higher below ground activity than the oil palm initially. So again, can we restore these river margins to better replicate, closer match these forest levels? And we also have another example sound. But the high-pitched ringing will be from these layers, and then you just have more thuds, especially when you have some headphones in, and you can hear all of this. So in the analyses as well, what we'd actually do, because we're focusing on below ground only, is we would apply what's called a high pass filter. So essentially we'd crop out all of this top area, all the above ground noise, we would crop out and then run all the indices on this below ground activity, and hopefully we can find something interesting.
What's the number that I expecting?
These, so that's the frequency, that's the hertz. So typically below ground, because it's more digging, burrowing, it's going to be sort of lower tone. So if it's a lower tone, it's going to be lower on the hertz. Whereas a higher tone, so if a really high pitched, we're going to have it further up, which is why the bird noises, which are high pitched, are sort of higher up. Yeah. So the main purpose of my first field season, which is pretty much now complete, apart from some lab work that I've got to do. So from the forest donor samples, what we've been doing is we collect it, let's say we collect it on a Monday, because it's so far away, we have to deploy it the following day. So to ensure the viability of the samples, we are quantifying the live versus dead specimens. So going through by hand, counting any live insects, counting any dead insects, just to make sure that not too many are dying during the collection and transport, etc. We're also we're going to be identifying the species that we can find in these samples, so we have an idea of what we are introducing, what are these key soil communities that we're introducing, and then we're comparing these with some samples that we take from the rotor plot, so we can actually see, okay, in the existing plot we have X, Y, and Z species, but we don't have any of these species from the forest, which we are now introducing. So will we see the results in 6 months' time? And yeah, so there are, like I say, there's so much data now, which is ready to be analyzed as well after the lab work. So hopefully when I return between September and November, I'll have some real results that I can present to everybody here. And then, yeah. So this entire project is only possible through incredible collaboration between all of us. And so, yeah, thank you very much for listening during the busy exam period. And I do look forward to hopefully seeing everybody again when I can come back with some results.
Oke, thank you, Dean. Jadi Dean ini memang baru penelitian masih awal. Jadi tadi yang disampaikan adalah metode ya dan alat-alat apa yang dipakai dan datanya itu baru dikoleksi kemarin. Jadi memang belum sempat ngolah, belum apa-apa. Tapi kami minta untuk share karena metodenya kan keren banget ya. Kita di sini belum pernah melakukan itu. So, ada pertanyaan mungkin? Pak Per, mulai dulu. Udah.
Sambil
Oke.
pakai apa? Pakai
Pakai itu bisa.
nyambung. Ya, bahasa Indonesia aja ya. Dean, I think a lot of your method is very interesting, so we learn a lot from you. I'm particularly interested in using the acoustic. So, is it very difficult to construct the device, or you have to buy ready to be used? Yes, you can use that. Because I also talked to Becky. I think I'm thinking to use that for monitoring insect activities in the trees or something like that. So I can record when the insects start eating and so on. So I'm thinking to get that. Is it easy to construct, or we have to buy ready or something like that? Or you will have some of your device, for example.
So the devices themselves, they already come sort of programmed with the software. So all you do is you download an app to your computer. And so you'd plug in, you'd have a cable that connects to your computer, you plug it into the AudioMoff device, and you choose your settings, configure your settings, and that is it. Very, very easy to do. And then you can connect your microphone. Although some of the devices come with a microphone already fixed, which is sort of why they're used for above ground. So if you're recording below ground or the insect noises, because they're obviously so quiet, what you'd likely need is a contact microphone that can pick up these quieter noises, as well as a small device which is called a buffer amplifier, which adds an extra 10 decibels, which I'm not an acoustic person, but pretty much all it does is any quiet noises that you hear, it just amplifies them. So you can, again, you've got meaningful results that you can listen to. The difference between having bird noises and insect noises is right now there's software out there, such as BirdNet, which you can sort of use to give you an idea of what species are making what noises, but there isn't something out there for insects yet. So unless you know what you're listening for, it is hard to interpret what's actually making the noises.
Yeah. Yeah, even Becky actually mentioned that the database in the computer mostly brought from UK. So when Becky collected the sample from Sumatra, some bird is not in the database, so it's not identified because the program it mostly contain database from bird in UK. Yeah, so we have to add some more bird or something. Yeah, and for insect, it's not available yet, you said, right?
Yes, not available just yet because, again, it's only over the past few years sort of been gaining more attention. So hopefully within 5-10 years, maybe there could be something that does sort of pick apart what animals, what insects are making what noises. But I suppose there's always potential for students to actually work on that as a project as well, which could be very useful for a research project, PhD, master's student.
Okay, thank you.
So if there's no database yet, and then you're recording it, how will you identify who is what noise?
So for this, we're not actually identifying what insects are making what noise. It's just a general activity that we can use to compare between the treatments. So this will pretty much tell us under what treatment and under the transplant treatments, what is the preference for these insects? Do we have higher activity, below ground noise in the retained palm or the enrichment planting areas? And again, especially after we make these transplants where we're actually introducing these key communities, do we see that these areas in comparison to the control group have improved over time?
Oh, wow. Very interesting.
Hmm.
Ada yang mau tanya tentang metode atau alat-alat gitu ya? Bahasa Indonesia boleh, jangan malu-malu. Itu tadi ada alat yang ijo-ijo bisa diituin enggak? Ada alat. Iya, silahkan. Siapa? Billy.
Ya, saya akan bertanya dalam bahasa Indonesia.
Yeah, so this is Billy, he's a master
Ya,
student.
Nice to meet you.
nama saya Brili. Brili.
Billy.
Biasa dipanggil
Billy.
Billy. Saya ingin bertanya terkait akustik underground because I have a little bit research about Corcolionid acoustic. Dan pertanyaan saya untuk tampilan analisis spektrogram ini menggunakan software apa? Soalnya agak berbeda dengan tampilan yang saya gunakan, itu menggunakan Raven Pro. Tidak tahu kalau yang ini menggunakan apa, biar mungkin saya bisa menyesuaikan lagi, mempelajari terkait dengan tampilan yang lebih bersih.
The software, it's a free software, so it doesn't cost anything, and it's called Audacity.
Audacity.
So that's Audacity, and it's completely free. There is better software out there. So there's one called Raven Pro, but that is a paid subscription software. And again, that might, I believe they do the same job, but for maybe bird noises, I assume that's why it's called Raven Pro. It might be better suited. But again, for this, because all we're trying to do is get the general activity, we just use Audacity because it's free. It's very, very easy to use as well.
Thank you. Yang hijau tadi habis ini, ha? Yeah. Okay, so if you can, yeah. So it's called an audio moth.
Audio moth.
When I first heard it, I thought you were going to listen to a moth, but it's
No.
just a name, yeah.
Yes.
Okay. And so did you assemble this? So you
You buy that.
buy that.
Yes, yeah. So you buy this device, and this is, so they have a few different models, and typically in their normal model, the AudioMoth 1.2, it doesn't have, so this is a 3.5 millimeter jack where you can connect your microphone. And so it doesn't normally have that. And this device, I don't have a better picture, but it's very thin because all it is just this circuit board. The thickest part is the 3.5 mm jack, which is very small. In the normal device, so this is the dev model, because in the normal device, it comes with a built-in microphone. So you can't connect a contact microphone to it. And in the normal one, it's a bit thicker, because you have a battery pack on the end, so you can put your batteries in. Whereas for this one, so this input space here, that's where you connect your external battery pack. And then you have your microphone, your SD card, and this is where you plug it in to your computer so you can configure it. And the rest, you don't really use the rest, but they can be used for additional LEDs. But typically for us, we don't use the LEDs while we're recording because we try not to attract any more rodents so we don't have issues like this. And you can buy cases as well, like plastic protective cases, which we probably should have done because, you know, we've just been using bags. And if moisture gets in, it can be problematic. Although this hasn't caused, the moisture hasn't caused any problems for us, but it can do. We can just expose circuitry. And this metal extension there, that is the buffer amplifier. So this is the contact microphone. And this area, this is where you put the probe that connects to it, 4 inches long, and you put it in the ground. But yeah, mainly for the issues, the audio off, I'm not sure what broke them, whether again it be a rodent or a monkey. But we have a few of these cables that we need to try and reinforce because you'd often get ants or again mice that would just nibble through the cables, and then obviously you lose that'll be more money.
Yang lain, pertanyaan apapun. Alhamdulillah, silahkan.
Terkait restorasi lahan, Bu, kan metode yang tadi disampaikan kan penelitian yang lain itu biasanya dengan restorasi vegetasi. Sedangkan DEN ini menggunakan metode transplantasi serasa. Dalam bayangannya DEN itu jika dibandingkan dengan restorasi vegetasi yang memakan waktu 10 sampai 30 tahun. Kalau serasa ini bisa memakan waktu berapa lama untuk perbaikan restorasi di sempadan sungai itu? Dalam prediksinya DEN.
So he's asking about the restoration with the litter. So if with restoration you need 10 years, 30 years?
So
For the litter?
hopefully not. So typically we yes.
Online can. Okay.
Yes, so typically with vegetation restoration, where somebody comes into the plantation, for example, and says, okay, we're going to plant 6 native tree species. Again, the problem is that these landscapes are miles and miles of oil palm. So we can't expect these key communities that drive these processes that we're trying to measure improvements on. We can't expect them to reintroduce themselves, migrate over in a short amount of time. So in a lot of research that's already out there in South, for example, it takes up to 30 years for just vegetation restoration to actually see improvements. And typically those are on larger landscapes as well. They're much bigger areas of deforested land, brown land being restored. So what we're hoping is by taking these samples from the forest, that we are collecting key communities, whether it be invertebrates or fungi, which are actually closer related biologically to animals than they are plants. So they're very important. And we're hoping that these will reintroduce them more so than the vegetation alone. So rather than it taking between 10 and 30 years to see improvements, we're hoping that we could see some improvements in 6 months. It would be ideal as well if we could keep doing the transplants. So in 6 months, we record the surveys, and then do some more transplants. So we just keep donating more, but my PhD ends next year. So I've only got 1 more field season available, which is why we're just doing the baseline before the treatments and then 6 months after. And there's an interesting paper from an Australian researcher called Contos, Contos. And they've done similar, where they have taken litter transplants, they call them whole of community transplants, and they have reintroduced them into grasslands in Australia, and within 6-7 months, they found that they had significantly improved the abundance and diversity of beetles, for example. So we're hoping that we can actually see the same in these river margins.
Okay, so basically the litter maybe you can use both. So the litter is to expedite the process, and then you still need the vegetation and the for the replanting process.
Yes, yeah. So you keep the enrichment planting because in these retained river margins, really you need the diversity in the vegetation because they all have many different benefits. So the leaf litter from all the different trees will have different sort of components, and they'll break down quicker, break down slower, which means there's different, more diverse nutrients going into the soil and improving overall soil health.
Oke, jadi yang menarik dari penelitiannya ini, biasanya kita kalau bisa dengan restorasi, kita akan tanam tanamannya. Nah, dia bukan hanya nanam tanaman aja, dia justru serasahnya itu dia pindah-pindah juga, dan itu ternyata bisa mempercepat proses restorasi, terutama untuk tanah. Jadi kumbang-kumbangnya kembali lebih cepat. Dan ada studi di Australia melakukan itu dalam waktu 6 bulan, kumbangnya itu sudah kumbang apa ya, lupa tadi Pak, tapi dalam waktu 6-7 bulan itu restorasi permukaan airnya sudah kembali. Jadi penelitian kayak gini kan membuka wawasan bagi kita ya, kalau kita kan itu aja misalnya kita jadi gini, oh iya bisa gitu juga ya. Nah, penggunaan akustik mungkin ini masa depan proteksi tanaman juga harus naik ke alat-alat itu ya Pak Pur ya. Ya jadi kita bisa pakai berbagai macam alat. Oke, di online ada yang bertanya?
Ada, Bu.
Ada, oke. Apa pertanyaannya?
Ya.
Oh, oke. So there's question from the online. Oke, jadi terima kasih yang sudah bertanya dari Nurfianto. Oh, oke. Mari kita lihat satu-satu. Yang pertama ini, question to the, okay, Dean, so you can read that. What will be the optimal microphone depth to accurately represent the composer activity within the litter layer? And do you think it is feasible to develop predictive model that relates sound to litter biomass? Okay, 2 good questions.
Very good question. I mean, the optimal depth for decomposer activity, probably 2-3 inches, because again, it's the most fertile layer of the soil, especially with the contact microphones. As we can see in the bottom left image, they just sit on top of the ground. So if you had leaf litter surrounding that, you'd probably get a good indication of the leaf litter decomposers themselves, maybe without the probe. So we use the probes pretty much just to, again, get the acoustic soundscape of the below ground general activity rather than just the decomposers. In terms of developing a predictive model, I'm not too sure. Yeah, I'm not too sure on that. I'm very new to acoustics themselves. We've only been deploying these over the past 4-5 weeks. I'm sure if Becky was here, she would probably have a better answer because she is an expert. So, I mean, if you do ever have any audio moth acoustic sort of soundscape questions, because she sort of specialized in audio engineering, you could reach out to her. I assume she would be on LinkedIn, and she's Becky Heath.
Okay. So thank you, Lutfi, for the question. Next. Nurfianto. I would like to ask about the approach taken with litter management. Whether the current condition of oil palm plantation has very little litter being returned to the soil, and whether in the future the planting pattern model that will be advocated is oil palm agroforestry to increase the litter biomass. Yeah.
So this is why we also record the habitat to the vegetation survey. Again, with the plots being very different in terms of the structural complexity, it really depends. So some plots do have, some plots might have 30 millimeters or even 100 millimeters of leaf litter and a humus layer. So if we, on the presentation, if we back a few slides. There's an image around holding a humus layer.
Not responding.
It's not
This one? No.
No, I've got like a big chunk of the humus layer, but I mean, even in that baked lamina one, we can see it's pretty exposed there. But it's all dependent on what the structure is like. So whether it be, typically what we actually find is if there is sort of between 2 and 4 meters above ground, if it's very dense with vegetation, then we would be finding that actually the ground is pretty bare, whether it be blocking out sunlight or whatever it may be.
So the litter is not. It's not.
So
Quite little. It's.
sometimes there can be, so in this example here, I suppose, we can see that there is leaf litter around the litter bags.
Yeah.
But again, it really is dependent on what plot you go to.
Yeah.
And some of the treatment. So in treatment D, where we have the control, which is just oil palm, replanting with young oil palm, typically we won't actually find much leaf litter there, especially there's no diverse leaf litter apart from maybe a few ferns or oil palm fronds, because there is no enrichment planting. But if we go to treatment A or treatment C that have the sick native tree species, then I'm sure this is probably an image taken from one of those. We do have the more diverse litter. And again, in one of the images,
Which slide?
slide 10.
Slide 10. Wait. Not responding. Not responding, Bu, bentar. Kayaknya berat di foto deh kayaknya. Crash.
Dari 10.
Ya. Tinggal mundur 2 slide aja. Ini pending.
Mundur 2. Oke, satu lagi.
Pending.
That's yeah. It's the picture.
Okay, this is it.
So this is an example. This picture is taken from the forest, and I mean we have much more leaf litter on the ground, and the humus layer. Again, I was squeezing that really tight, really firmly, and it's so dense there. So this is also what we're trying to transplant with the litter, because this is where a lot of invertebrates and microbial communities actually reside. And then we use the soil at the top. We scrape from the top 5 centimeters of the soil, because when these areas do get really hot weather or even harsh rainfall, invertebrates can often reside in this upper 5 mil superficial layer, we call it, to sort of get away from the extreme conditions. But there was I can say that compared to the plantation, there was no plot that had a humus layer this thick. So we went through in our vegetation surveys, and I'm pretty sure the deepest area of litter and humus layer was maybe 3-4 centimeters, so 40-50 mil. Whereas here, depending on where you went, it was very, very deep.
Okay. Okay, thank you. Oh, there's another question. Will it be advocated all park agroforestry in the future to increase litter biomass?
I think this is why, you know, we can test what treatment is best. Again, if we have the enrichment planting proves that we're actually improving these processes more so than just the retained oil palm or the control group, then this does give us sort of an idea of how we can shape these policies to include more native vegetation that again does offer different, more diverse litter input, but again will give more nutrients and also offer a refuge for more invertebrates, which can then hopefully make our soils in these areas as healthy as it is in the native tropical forests. So hopefully, again, our results will eventually go on to include a planting pattern model.
And so the next one is from Malik. How the device's accuracy detect micro activity, distance, and sound.
So we use, I think it's 36 hertz. I can't remember the exact configuration right now, but essentially, so the human hearing range is between 220,000 hertz. So using these specialized contact microphones and these audio amplifiers, we capture the full spectrum of sound. So they are pretty accurate in terms of recording activity. In terms of the distance, not too sure again, because it's all so new and only just developing on below ground activity in particular. I don't think it does give us a good indication of how far away the activity is from the device. But that being said, there is currently people, including Becky, who are working on these devices where they set them up at different distances from a certain area. So eventually they can try and integrate how well they are recording distance. Yeah. And devices per hectare. So we don't really, in terms of hectares, I'm not too sure. So our plots, so we have, again, the river margin restoration. The restoration is a 50-meter buffer that spans 400 meters in length. And so we've got 4 treatments on both sides of the river. And then we have a core vegetation plot where all surveys are conducted that's 25 meters in. So it's in the center of these buffers. And one will be, so on the west side, it will be 50 meters in and 250 meters in. On the east side, it will be 150 meters and then 350 meters. And then that's repeated for all of the treatments. For the audio recordings, we've been deploying them in the litter transplant plots, which on slide 18. So where we have the core vegetation plot, which is it's a 25 by 25 meter plot, in the very center of that, we've set up the 9 meter square grid where all of my surveys are conducted. And then outside of the 25 meter plot, we have the 2 transplant treatments set up, that will be randomized to avoid any pseudo replication sort of thing.
So you have 25 times 25 meters plot, then you have a 9 meters grid, and then you have 2.
Yes, so
Yeah, and the
one,
transmitter is inside the.
yes, so
Right.
the 25 by 25 meter plot, which is either 50, 150, 250, or 350 meters within that 400 meter area of the treatment in the buffer zone, and then adjacent to those 25 by 25 meter plots, we have the transplant treatment set up so that because there's so many different surveys being conducted in that 25 by 25 meter plot, we didn't want to introduce a litter sample there, so it may skew other people's results, which is why we have treatments in the top right corner on the outside.
Ya, jadi itu jawabannya dia nggak menghitung per hektarnya berapa ya, tapi memang bisa dihitung dari gambar ini ya. Jadi 25 kali 25 di dalamnya ada 9 meter square.
So
Transmitternya ditaruh.
in total, in the buffer core, plus the litter transplants, so because of, again, the issues with some of the devices failing, being broken, whatever it may be, we had to reduce
Okay.
our treatments. So for the transplant treatments only, the surveys were conducted in passive, active and control. So we're only comparing treatment A, B, and D. So we've got mature palms plus enrichment planting, mature palms only, and then our control group, which is replanting with young palms. And so plus no seeds, and plus these, so with all these additional transplant plots in total, we have 72 plots that we're recording surveys in, which should, again, especially because we're doing it over time as well, gives us plenty of data to actually have a good comparison between them.
Okay, thank you. One more question.
Oh, bukan.
Oh, bukan. Bawah lagi.
Di sini.
Udah nggak ada ya?
Iya.
Oh, okay. Well, I think that's all. So, pas lagi waktunya. So, thank you so much. Kita let us give a warm applause again to thank you very much. Dan terima kasih sudah hadir dalam acara hari ini, dan terima kasih pada teman-teman yang masih di online. Semoga apa yang kita pelajari hari ini bermanfaat dan menimbulkan keinginan untuk selalu melanjutkan riset-risetnya. So, terima kasih. And thank you so much, Dean. It's a pleasure having you here. Oke, ada sesuatu yang mau diberikan pada Dean dari Pak Pur. Oh, okay. So we have something to give you.
On behalf of the department, the certificate, thank you very much.
Thank you.
Thanks for the. Another one.
And then this is the sponsor from the department.
Thank you.
Okay. Ya, sudah hadir. Pada teman-teman yang di online, terima kasih sudah hadir dan sampai ketemu lagi.
Kalau masih ada pertanyaan mau langsung tanya juga.
Oh yeah, they can ask you directly if they want to ask questions.
I forgot to put my email on there.
Okay.
My email is just my name, so Dean Joyce @nottingham.ac.uk.
Okay.
So feel free to
Take it now, Joyce, and Nottingham.
AC.
AC.
Boleh, boleh. Iya. Terus di oh, perspektif.
Thank you.